So as we discussed a lot of problems yesterday or in the last class, like we had lot of problems related to Newton's second law, bodies moving with constant accelerations, constraint theories. We'll extend that constraint theories like as we discussed a string constraint yesterday, like to find out that the length of the string doesn't change, or we found out the velocities and accelerations of the objects connected through single string or multiple strings. Now let us have another constant that is called normal constraint. Normal constraint means, here I say, bodies to remain in contact the velocities and accelerations, velocities or acceleration I can say, or accelerations, or I can say relative velocity or relative acceleration along the direction of normal force, normal or contact force, should always be 0. For an example, I say, let us say this is a wedge and this is the body which can, like, it has to move in this direction, this body. Let us say the body, this body is accelerating with downward with an acceleration a. This wedge is moving forward with an acceleration a2. This angle is theta. We need to find out the relationship between this acceleration and this acceleration. Now, first of all, I take this body which is moving with an acceleration a1. Now, on this body we need to resolve, or we need to find out the direction of the contact force. This wedge must be giving a contact force in this direction. So I extend the contact force line. So this angle is theta, obviously this angle will be theta. Now let us resolve this acceleration along the direction of the normal contact force line. So I can say this is contact force line. So this becomes a1 cos theta. Now let us take this wedge. This is moving with an acceleration a2. So I take here this. Now we'll again find out the contact force line on this wedge. This body must be giving a normal force in this direction. So again I can write this is contact force line. Now this is theta, so this will be theta. Now this will be, this is a2 cos theta, this will be a2 sin theta. Now for the bodies to be in contact, this acceleration, relative of acceleration between this acceleration and this acceleration must be 0. So this a2 sin theta and this a1 cos theta are in the same direction. So I can write a1 cos theta minus a2 sin theta must be equals to 0, or a1 is equal to a2 tan theta. Or I can directly write tan theta is a1 by a2. This is the relationship between these two accelerations by the method of normal constraint, we can easily find out the direction or the relationship between two acceleration as well as relationship between two velocities if it would have been given.